Hello, I'm Phil Kithill, founder and CEO of Ocean-Based Climate Solutions and also of Atmocean, the parent company founded in 2005. So a lot of questions come up. Where did we get started? How did it all come together? So here's a slide deck showing with pictures our progress. And it did start in 2005, the idea prompted by Hurricane Katrina hitting New Orleans. Can you use the high, big waves generated by a hurricane to bring up cold water and reduce hurricane intensity? And we built a pump. You can see it here on the field in Santa Fe in the soccer field. Took it out into the Gulf of Mexico and tested it, and actually got underwater photos of the water being pushed upward by the one-way valve at the bottom. Then we're invited to Bermuda, Bermuda Institute of Ocean Sciences. Took our pump and checked baggage and got to Bermuda, went out on the weatherbird. There's Rod Johnson, one of their lead scientists there, along with a couple people I brought along. And we deployed the pump and it worked. First time out, 500 deep, bringing up cold water just on wave energy. Continued our work in 2006. And one of the questions, how do you get this thing in the water? So one of our second tests off Corpus Christi is wrap the tube around the pump and drop it overboard. The heavy weight sinks and unrolls the pump. Built a bigger model and took it out, sponsored by Discovery Channel of Canada, and deployed it off San Diego, and also began to promote the idea. In 2007, built a bigger pump, 3/4 meters, 30-inch diameter, 500 feet deep. Put accelerometer on the bottom flapper valve and temperature sensors top and bottom. So we got data showing exactly what was happening, and began more marketing, popular science, the rapid climate change in the North Atlantic, reoxygenating the deep waters in the Gulf of Mexico after the Horizon deep oil blowout. Didn't get the contract. In 2008, invited by Discovery Channel to participate and provide our pumps for a test in Hawaii. There you can see on the second left picture, Professor Dave Carl, Brian von Hertzen with a light blue shirt, and the Discovery Channel producers, and the University of Hawaii boat in the distance there. Built these in Albuquerque, shipped them out, and they were deployed, worked for a while. Some issues, as there always are, and it was a great experience. 2009, shifted gears, tried to eliminate the tube. So we had a tubeless design called the variable sea anchor. You can see the design sketch there. We actually built one, instrumented it with a GPS, deployed it off San Diego, and tracked it for 30 days. And it threaded its way between the island and the mainland about halfway down. That was the first indication that the pumps would not wash up on the shore. In fact, they would follow the contour of the deep water in between an island and the mainland. Picked up by the Mexican Navy, that's a whole nother story. 2010, refocused our effort on generating electricity using wave energy. Presented this to Richard Branson. Again, did not get the contract. 2011, went out to San Luis Obispo, to the Cal State, Cal Poly, and they have an ocean test pier. So we built a rig to imitate the up and down motion of the wave. And you can see, we actually were pumping water using that rig with the variable sea anchors, providing the resisting force. They are hanging beneath the pump. Took that same rig to Plymouth University in the UK for some wave tank testing. Made a 1/20th scale units. There we learned that scaling does not work when you go in a wave tank. So go back to full size. Funded by Oregon Wave Energy Trust. In 2012, built some units, shipped them up to Coos Bay, Charleston, Oregon, and deployed them out in the open ocean. Got a permit from the U.S. Coast Guard to go out beyond the 3-mile limit in federal waters under a wave energy exemption. Great learning curve. Learned how to get things on a boat, off a boat, back onto the boat. Built some rafts, pontoon rafts, to get the variable sea anchors out there. and so on. Continued that effort in 2013, changed the sea anchor design a little bit, deployed the unit. The Oregon State scientists came by with their underwater acoustics and tried to characterize the noise, underwater noise, acoustic signature. And in fact, this particular design was very quiet. They didn't even hear it. They heard container ships far out at sea, but they did not hear our pump operating. It was a worthwhile effort. 2014, continue to work on the modeling with Sandia National Laboratory. Here I am with Senator Dick Durbin and Tom Udall at the lab in a presentation. And then in 2015, we able to get funding to do a project in Peru. And we built the pumps in Albuquerque, shipped them down to Peru, built the buoys in Peru, in Lima, and did some offshore testing in Ilo, in the southern part of the country, almost down to the northern part of Chile. 2016, with the same unit, we wanted to know what were the effects of cross currents, and Texas A&M had a wave tank that they could simulate the effect of currents in the left side tank that you see there. Our COO, Chris White, got to present at the UN that September, and we changed our direction to zero electricity reverse osmosis, pumping seawater onshore powered by wave energy into a desalination container and then desalinating, drip irrigating the coastal deserts. We could do it, but not cost effectively. Our cost per cubic meter, I believe, was on the order of $2, best case, and that was about 20 times higher than agricultural end use would support. Continued the effort in Newfoundland at the Wave Energy Test Center, built another buoy, actually in Truth or Consequences, New Mexico. This just demonstrates you can build these things anywhere. Built the rest of the pump in Albuquerque, put it in a truck, shipped it up to Newfoundland, reassembled it, and floated it out to the test site and deployed it. 2018, switched gears with our spin-out Ocean-Based Climate Solutions, presented at the Negative Emissions Conference in Sweden, invited to the Global Climate Action Summit in San Francisco, began to look at the upwelling and downwelling combined in one unit, did a quick test off San Diego in the center pictures there, then built a full-scale unit, a larger unit, not yet full scale, and deployed that off Morro Bay, California, demonstrated that the deployment mechanism worked, the raft, wrapping the tube around this larger buoy and then converting that buoy into a raft shape after it's fully deployed happens hands off and totally successful. 2019, spent most of our time on fundraising, presenting at Verge in 2019 at the Sustainable Ocean Summit in Paris in November that year, and introduced the idea of salinity adjustment to the ocean to help counter the meltwater coming off Greenland, which could disrupt the global climate quite seriously. 2020, continued our technical initiatives with oxygenator, upwelling and downwelling, converted the tube into a unitary design with no junctions, no splices, no stitching together of different fabric panels, and invited by both Stripe and Microsoft to submit to their request for proposals. A great learning experience, not selected by either, but now we are completing our second Stripe request for proposal due next week. We've taken some big steps business-wise, retaining our Director of Marketing, Salvador Garcia, our CFO, Chris Economo, just last week, and we have a couple of interns who are starting up. Our design is basically complete. It will be upwelling from 500 meters to 15 meters, separately from downwelling, which would be from the surface down to 300 meters. That's the most economic application. And so we are expecting others to become interested as we proceed through the year. So that's our summary of where we've been and how we got here.